Okay, well, good evening, everyone. Welcome to Amateur Astronomers Incorporated, also known as AAI, for our weekly presentations. Now, my name is Mary, and I'm a member of AAI. And AAI makes its home at William Miller Sperry Observatory on the campus of Union College in Cranford, New Jersey. Something important to note that in 2024, AAI will be celebrating its 75th anniversary as an amateur astronomy club. The observatory is now open to the public on Friday nights for observing through our two large telescopes, which is a 10-inch refractor and a 24-inch reflector, and also to have weekly presentations on an astronomy-related topic at 8:30 p.m. Now, our plans are to stream these weekly presentations live on our Facebook page and on YouTube when possible, in addition to being in person in the observatory. And our website is www.astrosm.org. You can find out a lot of information about us, including committees that we have, the upcoming presentation, which is listed on the homepage, how to join AAI, and if you'd like to donate to AAI, and if there are any special events. Now, if you are a scout or youth group leader, we give presentations, programs that is provided for your group. And to get your group scheduled, you can go to the homepage on the website and click on the contact button, and follow the instructions on how to get scheduled. You can also follow AAI both on our Facebook page at Amateur Astronomers Incorporated and on Instagram at amateur.astronomers.inc. Our presenter this evening is AAI member Dr. Clif Ashcraft. Clif has been a very long time member of the club. He actually helped design and build the 10-inch refractor that is housed here in the observatory. He's done a lot of imaging of the night sky because he has his own observatory and telescopes and camera equipment. The title of his presentation this evening is My Astronomical Journey. And with that, Clif, you can begin.
Thank you, Mary. This talk is autobiographical in nature, and it begins when I was with the eclipse of the moon on August 25th, 1942 in Cincinnati, Ohio. I was 3.81 years old, and you might wonder how I know I was exactly that old. But my mom let me stay up past 11 to watch the eclipse of the moon, way past my bedtime. It was beautiful and got me hooked on astronomy. There were only two eclipses of the moon that year, one on March the 2nd and the other one on August the 25th. And we had moved after the first one, and I knew I was at the new house when the second one occurred. I also got some early lessons from my mother's science fiction magazine covers: planets, rocket ships, alien life forms, otherwise known as bug-eyed monsters. Mommy, could I go to that planet? How does that rocket work? How far away is Pluto? Early learning with my parents' help. I was making solar system diagrams with labels by age 5, and they included the planet Pluto. I got science-oriented Christmas presents, microscope sets, chemistry sets that did stuff like explosions, books, both scientific and literary. Bob got me the Iliad when I was 7, but it wasn't in Greek. I was trying to make telescopes with eyeglass lenses and magnifiers, and I was looking at the advertisements in Popular Mechanics magazine. Any of you remember this ad? No, not the thing on the right about the guy with the accordion. I mean this one. 250 power complete telescope lens kit, only $3.49 postpaid. Wow. Does this sound like what I want? Look at that. Lenses, all necessary lens fittings, easy to make from simple step-by-step instructions. Wow. Or they don't give you a tripod and mount. Well, I guess I'll have to build that. I collected pop bottles for weeks to get enough money to order this exciting treasure. Now, this was Ohio. You might say soda bottles, but I collected a lot of them until I had enough money to order this. Well, when it arrived, I got this. I got very flat objective lens, supposed to have a focal length of about 80 inches. I got another little magnifying lens that was supposed to make a 50 power eyepiece. And I got 4 other little fisheye looking lenses that were supposed to make 100 power, 150 power, 200 power, and 250. I could hardly wait. And then I kept opening up the package. This is all necessary lens fittings? Oh my goodness, it's a piece of cardboard with these little donuts printed on it. Well, evidently I was supposed to cut 3 circles out for each lens and make a little sandwich like this, holding the lens in between 2 pieces of cardboard sitting in the other one. And for detailed instructions, it said, ask your mother for a spool from her sewing kit. You can make 2 eyepieces by sewing 1 spool in half. And it told me to ask my dad for a downspout gutter pipe. You know, a big long tube like that. Well, I got it done. I cut out those little donuts with a razor blade and got it sort of mounted together and made a couple eyepieces. The result was not pretty. It had a cardboard tube from a toilet paper roll and lots of tape to hold my eyepieces on one end of the tube. And it had a thing on the other end that held the objective. When I looked through it with the low power 50 power eyepiece, that's the view I got of a tree on the other side of the yard. Well, it was closer. There was a lot of color, but I don't know if I saw any more. Then I tried the 100 power eyepiece. Well, it was bigger, but it sure wasn't any clearer. I was pretty disappointed. I tried the higher power eyepieces, but they just got worse and worse and worse. The real problem was that the objective lens wasn't polished to real astronomical lens standards. When I told my dad it didn't turn out as amazing as he had said it would, he said, "What did you expect for $3.49? He then said, more kindly, I thought, "I think you need a better lens. I'll go talk to Nathan." Now, Nathan owned a camera store pawn shop downtown on Vine Street in Cincinnati. Dad had known Nathan for years as a result of his part-time business as a studio photographer and knew that Nathan would have something for me to experiment with. Ever see one of these? This is an old-fashioned studio camera. You've probably got pictures of your grandmother or grandfather taken with one of these. There's a lens in the front and a ground glass screen in the back where you put photographic plates in and a snood to cover your head so you could look at the screen and focus it. Well, Dad brought me home a lens out of one of those old cameras. Now, when I took it apart, by unscrewing the ends, I found 3 lenses inside. 2 of them were actually achromatic lenses. One of them was a simple lens, and there was a diaphragm in between. Well, I quickly found out that all of them had a focal length of about 30 inches, and it looked like one of them might make a good telescope lens for me. He also got me this brass spyglass, and I figured if I unscrewed the objective off of this end, well, I could use this as kind of a telescoping thing, and it's already got an eyepiece in the end of it. So I had a plan. Well, this is what I ended up with. It had the lens, one of the lenses from the view camera in the front. It had the spyglass with the objective removed in the back. It had a diaphragm in the front with 1.5-inch aperture, because I found out it wouldn't work if I tried to use the whole thing, and an old tripod from a panoramic camera mount. This was also from Nathan. Well, here's the view out of my backyard towards a power tower in the distance. When I looked at it with my new telescope, this is what I saw. Wow, it really works. Brought it a lot closer and I could see a lot more detail. And when I looked at the moon, I could actually see some craters. And the Pleiades, I could see them as separate stars, not just a little blurry fuzz in the sky. I could see that Jupiter actually had moons, and I could see a hint of the cloud bands on Jupiter, and Saturn had rings. Well, couldn't see them very well, but they were on either side of the planet. I figured they had to be rings. Now I had me a serious telescope, at least serious for a 12-year-old boy. Well, I learned a lot with this telescope, but by the time I was in high school, I was beginning to realize the limitations of my instrument. I had to keep it stopped down to about 1.5 inch aperture because the old view camera lens I was using was not really intended to be used as a telescope objective. If I removed the aperture stop and tried to use it at its full aperture of 3 inches, everything got fuzzy because of spherical aberration. I had tried to see the canals of Mars in the 1954 opposition, but I got better views with my dad's surveyor's transit. But still, I didn't see any canals on Mars. Now, I had been reading the amateur telescope making books by Albert Engels and was now considerably more sophisticated about optics. I realized that I needed to make my own reflecting telescope by grinding, polishing, and figuring the telescope mirror. It didn't look too hard in the books. Well, Edmund Scientific had a kit that had all you needed for only $11.95. That would be about $120 in today's inflated currency. And here's what you got in the kit. You got a plate glass tool, a Pyrex blank for the mirror, a bunch of abrasives, some jeweler's rouge, some pitch, a little diagonal mirror, and a couple of lenses you could make yourself an eyepiece out of. Just everything you needed. Well, I decided I wanted the 6-inch mirror kit and persuaded my parents to let me order the kit for my Christmas present in 1954. Well, my dad was a bit skeptical, but was convinced by my arguments that it was not a sucker deal like the last time I had ordered something by mail. Well, I learned from the ATM books that I needed to get myself a barrel. And I needed to have a way to hold the plate glass disc on top. And then I'd sprinkle some abrasive powder, a little soapy water on the glass tool. Be sure to start with the coarsest abrasive first. And then I'd rub the Pyrex disc back and forth across the top of the abrasive. And then keep doing this using a W-shaped stroke. Every now and then you rotate the disc a bit and take a step around the barrel. You do this until the abrasive gets dry or wears out, and then you add more abrasive and soapy water and keep going. Eventually, the top disc becomes concave and the bottom one becomes convex. Took about 3 weeks of all my spare time to get it deep enough, about 46 thousandths of an inch deep. Well, from the formula I found in the ATM books, that 0.046 inches was the sagittal, the depth of the curve. And from this formula, I could calculate that the radius of curvature was 98 inches, actually 96 inches it was. And then I cleaned up so thoroughly that not a grain of the coarser abrasive was left, switched to the next finer grade of abrasive, and continue, and continue, and continue. 2 months later, I had finished with the finest abrasive, which was 3-micron emery powder. My Pyrex disc had just the right curvature to make a mirror with 48 inches focal length and a beautiful satiny fine ground finish. Now I got to polish this thing. I carefully melted the tempered burgundy pitch supplied with the kit in an old saucepan and carefully poured it onto my cleaned up convex plate glass tool. And I plopped the Pyrex disc into warm soapy water, and then, concave side down, I smooshed it onto the warm soft pitch on the tool, sliding it around to get good contact. Well, I then carefully slipped the Pyrex disc off the still slightly warm pitch, trimmed around the edges with a single-edged razor blade, and scratched a checkerboard pattern in the surface, just like they said to do in the ATM books. This gave me my polishing lap. That's what I'm going to polish the mirror with. I then made a suspension of Jeweler's Ridge from the kit in soapy water in a squirt bottle, went down the lap, and resumed the barrel dance, back and forth, round and round. Polishing went well. Surprisingly quickly, only a couple days, the surface became shiny, except for there's nothing visible on the surface except for a few pits from one of the coarser abrasive grinding steps. I didn't grind long enough with the next abrasive, but can't polish those out. It would take an eternity, but no matter, those pits won't hurt the image any. Let's see what we have. For this, we use the Foucault test by a Frenchman named Foucault. Here's what you do. You prop up your precious piece of Pyrex down at one end of the table, and back here at 96 inches away, the radius of curvature, you set up a tin can with a light bulb inside, a hole in the side of the can, and a piece of aluminum foil over the hole, and you poke a hole in it with a needle. You have a knife edge, which is just another single edge razor blade, and you put your eye behind it. Sounds dangerous, but I was careful. And you look at the mirror until you find where the image of the pinhole is. When you do that, you see something like this. The top picture is what you get if the knife edge is inside the focus of the pinhole. The bottom is what you see when the knife edge is outside. And if you have it right exactly where the image of the pinhole is, you get a highly magnified view of what the surface of the mirror looks like. This is easy to set up and use, even by a kid. I made it all myself. You could see defects on the surface only a few millionths of an inch high. My mirror had become a lumpy sphere, a lot like this image here. Well, figuring, this was the hardest part. I spent the next 6 months wrestling with that lumpy sphere. The perfect paraboloidal surface that would give me the sharpest focus was supposed to look a bit like a donut on the Foucault test. I got all kinds of strange figures, but finally got it right with the correct delta R, change in radius of curvature for the different zones according to the formula in Texero's book. It looked like this, nice and smooth, no turned down edge. And all of my measurements were just like they were supposed to. I then wrapped up my precious piece of Pyrex in cotton batting and packed it in a plywood box that I made and entrusted it to the U.S. mail. I sent it to Leroy Clausing for metallizing with beryl, which is an alloy of aluminum and beryllium. And he only charged $3.50 to do that. Here was the ad for Leroy Clausing, and there's his schedule of prices. Hey, he'd do a 12.5 for only $9.75. Well, it survived the trip, and when I got it back, I thought it was the most beautiful thing I had ever made. This was in 1955. This is what my mirror looked like. And by the way, Dudley, Leroy's son, is still coating mirrors. He charges a lot more now than his father did, though. There's the link to Dudley Clausing's enterprise. Now to mount it. Well, I got the old tripod that Dad got from Nathan, and I removed the alt azimuth top, the thing that steered the panoramic camera around. That worked fine for my simple telescope. I borrowed some pipe fittings from Dad's plumbing supplies, and I filled an old coffee can with cement to make a counterweight. And then I scrounged a cardboard tube from the trash, and I mounted my optics. Wow, William Herschel should be so lucky. The telescope worked great. It was all I could hope for. I finished the mounting in the summer after I graduated from high school in 1956, and I used it with improvements to the mounting until I built my 10-inch reflector in 1970. I still have the 6-inch mirror. What I could now see. When I looked at the moon, I really got good close-up views of the craters on the moon and the Maria. and the mountains and the ridges. It was amazing. When I looked at Saturn, I really saw the rings. I could even see Cassidy's division. And those little tiny specks of light near Saturn, well, that one is Tethys. There's Dione. There's Titan, Enceladus, and Rhea. 5 moons of Saturn that I could see with my 6-inch reflector. Now, activities that I had with the 6-inch telescope over the years, I learned the craters and feature names on the moon. I learned the cloud belt structure on Jupiter. I could sometimes see the Cassidi division on Saturn's rings, depending on the seeing. I still did not see canals on Mars. I found out I could see Uranus and Neptune, but I never was able to find Pluto. It was just too faint to see. Double stars, well, I could resolve some of them, not the really close ones, but lots of them, but I couldn't measure them then. I didn't have the equipment to do it. I learned about the collection of fuzzy nuisances that Charles Messier kept, the ones that turned out to be galaxies, star clusters, and nebulae. They were beautiful to see, but sometimes a challenge with a small scope. I did occultations of stars by the moon, ordinary solid occultation timings using WWV shortwave signals and a stopwatch. I participated in grazing occultations with the U.S. Naval Observatory. We did a lot of schlepping of telescopes down railroad tracks and stringing mile-long cables to observe these grazes. Now, in 1960, after I'd finished college at the University of Cincinnati, I went away to graduate school in Berkeley. Now, while taking my chemistry courses for my coursework and organic chemistry research for my doctorate, I still managed to do some astronomy. The machine shop available for student use was a great place to improve my old pipe thread mount for my 6-inch reflector. And there I learned how to use a machine lathe and a milling machine, skills that came in very handy during the construction of the AAI 10-inch refractor. In my last year, I had enough free time from the chemistry courses to enroll in Astronomy 101 taught by Professor Paul Hodge. He was later department chair at the University of Washington Astronomy Department. During that course, I got to use the 8-inch refractor at Loister Observatory on campus. This gave me better views of Mars than I got with my 6-inch telescope, but I still didn't see any canals. And as part of a class project, I was even able to use the 12-inch refractor of Lick Observatory to see if the wave of darkening would appear and write a class paper on the subject. Well, here is the 12-inch refractor in the North Dome of Lick Observatory. It's not there today, but it was when I was going to school at Berkeley. A sketch from memory of one of the Mars drawings that I made that night. You can see the North Polar Cap, Mare Acidalium, and I thought this area was probably Mare Erythraeum, but again, I did not manage to see either the wave of darkening or any of Mars' famous canals. I thought this was because the seeing was just too bad. It was very, very windy that night, but at least I got to use the 12-inch refractor and I made the drawings for my class assignment. Hey, I was luckier than the assistant professor who gave me a ride up Mount Hamilton. He was planning to use the 120-inch reflector to study the spectra of Wolf-Rayet stars. But the wind was so high they would not let him open the dome all weekend. Well, when I finished up what I was doing a little after midnight, I closed up the dome and I walked out into the dark hallway with the big dome for the 36-inch all the way at the other side of the building. I heard music coming from the other end of the hallway. I walked over and carefully peeked in the door, and there I saw Dr. Hendrik Vandenbos measuring doubles with the filar micrometer on the 36-inch refractor while listening to Bach organ music on his portable phonograph. He's long gone now, but he still holds the record for the most visual measures of double stars. There's Dr. Van den Bos and the 36-inch refractor. AAI, Amateur Astronomers Incorporated. After I finished graduate school and got a job in New Jersey, in 1964, I learned about AAI from Roger Tuthill. My wife saw an article in the local paper that Roger wrote, and his phone number was in it. So I called Roger up and he recruited me. I joined the club and made friends with some really serious telescope nuts, and I learned a lot more about building telescopes in astronomy. I participated in the design of Sperry Observatory and helped design and build the 10-inch refractor at Sperry that's in operation to this day. More telescopes and observatories in my backyard added to my collection over the years, mostly homemade, but some were purchased. Here's that 10-inch Newtonian I was talking about in a later incarnation on a nice Losmandy mounting. I think that happened about 2002. I built this 8-inch Dobsonian in 1980. I got this Meade 10-inch Schmidt-Cassegrain. I think I bought that from Roger Tuthill. And I built this little shack observatory in 1998 to put the Meade 10-inch SCT in it. I later built my second observatory just to the south of it, and I installed the 10-inch Newtonian in 2001, and I used it to observe the 2003 opposition of Mars. Here's a picture of it with the roof panels opened up and my dog Noah sitting on the stairs. You can see the telescope behind Noah. I later built a 12.5-inch Newtonian and mounted it on the same mounting. And this is the one that I did a lot of double star measurements, not using a filar micrometer like Dr. Van den Bos was doing, but using a charge coupled device camera and measuring the separations of the doubles by photometry on the digital images I got. I then added another observatory in 2006, and here you can see it from a satellite image, and I installed a 7.25-inch Schuppmann medial refractor that I built in 2006. This turns out to be the best planetary instrument I have ever used. I then bought a Celestron CPC 1100 Edge in 2013, and I now have installed in the observatory that the 12-inch was in, I have a C14, and I use this for my galactic imaging. Cameras that I've used over the years. This is the Philips 2U-Cam. It's an ordinary webcam, just like you would use for online chat. But you rip the lens off of it and put an eyepiece adapter on it, and suddenly you got yourself a planetary camera. I used that in the opposition of 2003 of Mars. Here's the S-Big camera that I got for doing the double star measurements. And I did a little bit of deep sky with it, but it was mostly for the double star work. I got this wide field Orion large format CCD imager, and I did some fun deep sky imaging with that. And then I graduated to industrial strength webcam with this imaging source video camera a few years later. And I am now using the CMOS video cameras that are made by ZW Optical. Here's a picture of me and my dog Boomer, who was my member of my research staff at the time. He's no longer with us, and here's Chewy, current head of security. Some of the images that I've taken over the years. Here's some moon pictures that I took. These were taken by the Lucky Imaging method, and the large scale ones like this are mosaics of anywhere from 6 to a dozen images put together in Photoshop afterwards. This is Sinus Iridium and Copernicus. Some interesting effects you see if you watch the same feature on the moon over the course of several nights. Strange illusions. This one looked like some kind of space worm coming out of the crater, but you see it a couple nights later, it's no space worm. Nice pictures of the north side of Mare Imbrium with the crater plateau and beautiful shadows of the crater ridge mountains. More moon pictures, the wrinkle ridges in Mare Serenitatis, Gassendi crater, Schickard crater. Look at all the detail in the bottom of the crater. I even did a little bit of solar imaging before my Coronado Etalon failed me. You could see prominences on the edge of the sun, and here they are superimposed on the disk of the sun. I have images of Venus and even Mercury. This was taken in the daytime. You can see the crater Rembrandt, which is about 400 miles in diameter and is about the size of New England. I also looked at a lot of oppositions of Mars. It has an eccentric orbit, and the distances vary from 35 to 65 million miles. The first opposition I remember observing was a close one in 1954. I observed that with my homemade refractor and my father's surveyor's transit. The transit gave only 25 power, but it was a beautiful, crisp red disk, but no canals. The opposition of 2003 was the best in recent memory, and it was my first opportunity to image Mars through my 10-inch reflector and the little 2U cam, modified for astronomical purposes, a warranty outdated. I've imaged every opposition since then. After a series of unfavorable winter oppositions, they became gradually closer until 2018. It was as close as it was, nearly as close as it was in 2003. Here's the opposition that I looked at in 1954 when I was still in high school. And here is the one I looked at with the 12-inch refractor at Lick Observatory. It was a relatively distant opposition. Here's some images I got from the Mars opposition of 2003, which I was pretty proud of. That was the seeing was fairly good, that opposition, and you can see a lot of detail. This little lump here is where the rover Curiosity is right now. Of course, I had no idea in 2003 there would even be one. Here's Syrtis Major, Sinus Meridiani, Mare Erythraeum, and just the tip of Mare Acidalium that was in my sketch that I got in 1963. Solus Lacus. And here's the path that Mars took through the sky on that opposition. This is all of the pictures I got during that opposition. But this one is a special one. This is the June 3rd, 2014 opposition. Not the closest one, not the furthest one, but I had some good seeing. And if you look at this dark band here, I've labeled it, and there's lots of albedo features, but that dark band turns out to be something called Deutero Nihilus. And if you look at one of Percival Lowell's Mars globes in the museum at Lowell Observatory, you will see indicated down here, Deutero Nihilus. It corresponds to this dark feature, which I see in my image. So I finally got to see one of the Mars canals. Unfortunately, there's no water in it, and it's not a canal. It's just marking the continental slope between this high cratered plain and the northern abyssal plain where Mars used to have an ocean. No crater or no canal, but at least I saw one that Lowell thought was a canal. I have imaged a near-Earth asteroid These are several images taken of it as it's moving through the star field, and stack them all up together to give a trail. This was NEO 2002 RX-211, a near-Earth asteroid. Glad it didn't hit us. I've imaged Jupiter over the years. This is one of my better and early images I got on March 13, 2004 with the 10-inch reflector. And if you look very closely, you can see a light feature on the image of Ganymede as it leaves its transit of Mars. That turns out to be the bright area Osiris on Ganymede. Here's a little animation I made from those images. And you can see Io disappearing behind the planet and Ganymede and its shadow emerging from the transit. The shadow is bigger than Ganymede itself. Another image of Jupiter I took on 2016, and yet another image taken in 2015, where the red spot is nicely visible. Saturn, June 1, 2013. It was 826 million miles away at a time. And here is my images of Saturn over the years, all the way back to 2003 with the 10-inch reflector, up to my latest image on July 16, 2022, taken with the 7.25-inch Schumann medial. You can see that back in January 3rd of 2009, the rings were almost perfectly edge on and disappeared. You can see the shadow on the planet. And it also was disappeared again sometime in 2009. I have the Kuiper Belt object Makemake. It's actually further than Pluto. I also have an image of Pluto now, but I didn't include it on this slide. But there's the trajectory of Makemake, and here's my image on August 2nd, right where it's supposed to be, just north of that star, right there. A montage of lots of the images that I've taken over the years. Deep sky images taken with the Orion Deep Sky Imager, the Flame Nebula, the Horsehead Nebula, the Dumbbell Nebula, which I think it would be better called the Apple Core Nebula, M13 Globular Cluster, M31, the Andromeda Galaxy, M81, the Spiral Galaxy, neighbor to the local group, and M74, a spiral galaxy, 32 million light years away. Got a lot more of those, but you'll have to tune into my Exploring the Local Supercluster talk to see my galaxy images. One more, the Whirlpool Nebula, M51, before and after a supernova erupted on July 10th, 2005. Supernova right there. And that's all. If there's any questions, be happy to answer them.